Good morning, Abisters. We're almost ready to lunch. Alrighty, we're looking at increasing and decreased functions in the first derivative test. So here's our function right here. And we're starting out with a really easy one because everybody pretty much knows what f of x equals x squared is. You know, Elijah, you have a real cool back of the head. I've been admiring it lately because there's hair and spots that I don't have. All right. Critical numbers. The critical numbers. F of x is equal to x squared. The purpose of this, Julia, is to find what? What's the purpose of f? To find, not sure? Landry.
What's the purpose of f?
Yeah, what's the purpose of f?
To give you your function.
Okay, what's the purpose of the function? And how do you find your graph?
You plug different x values in for
And you get?
y values.
Y values. This is to find y values. Okay? What's then the purpose of the derivative, which in this case is 2x, Julia? To find what? Slope. Right? That's it. So if I want to find a critical number, what I'm saying is I want to find those numbers, those x's that give me a slope of what, Jack? I'll say it again. If I'm trying to find critical numbers, I'm trying to find those x values that give me a slope of what? 0. So I let 2x equals 0. And I get x equals 0, right? Which means I have one possible turning around point. Notice it's a potential turning around point. There doesn't have to be turning around points. But if this function has a turning around point, it has one at x equals 0. Does that make sense? So now I'm going to plug it into f and say, okay, what would that point be? I would get 0. And we know that there is a turning around point at 0, 0 on the function y equals x squared, correct? Because y equals x squared looks like this. It comes down from the sky, hits 0, 0, and bounces back up. Now, but you know, I'm using this as a real easy example. We're going to get ones that are a little bit more difficult. So what we're going to do is that 0, 0, this critical number, this is called the first derivative test. It looks like this little box right here. And you're going to start out with intervals. And since it's open intervals, we're going to have relative minimum and maximums. Since it's open intervals, our turning around points will be relative min or relative max. And the critical numbers are what go right here. So if I have one critical number, I am going to have two intervals. If I have two critical numbers, I'm going to have three intervals. So what's going to go here? The critical number, 0. In other words, I want to know what's happening to the left of 0, 0 and what's happening to the right of 0, 0. Well, we can see that the function is decreasing here, so its derivative better be what? Negative. So I'm going to pick a test number or a test value. And it can be any number that's between 0 and negative infinity. I usually choose the easiest numbers I know. And I'm choosing -1 and a +1. You could choose a -17. You could choose 75. But I'm going to choose something that's easy. And then I'm going to plug this in to the derivative. And I just want to know, is my answer positive or is my answer negative? Well, if I plug a -1 into this function, it's negative. If I plug a +1 into this function, it's positive. That means the function is doing what in this interval?
Decreasing.
Decreasing. And I know in this interval, Landry, it's doing what?
Increasing.
So if you look at the directions, it said find the open intervals where the function f of x equals x squared is increasing or decreasing and the relative extrema. Determine if it is, and we're talking about the relative extrema, a relative max or a relative min. Justify your answer. Well, I am going to say this, that in the interval, f is decreasing in the interval negative infinity to 0 since what, Jack? Since the derivative is negative. So that's how I write since the derivative is negative in that interval. F is increasing in the interval from 0 to infinity because Owen, since what?
Since the derivative is greater than 0.
In that interval. Those are how you write your justifications. Even though I use this symbol, you have to write out complete words in your justification. You are allowed this for negative and this for positive. Justin, 0, 0 is a relative because it's a, now you could argue it's an absolute minimum, right? But since it's an open interval, we're going to say relative minimum because it's less stuff to write. A relative minimum since y, since what, Justin?
It's at the very bottom.
Okay. It's at the very bottom? Yeah, it's not going to work. Since something changes. I'm not saying this. These guys give me truth all the time.
Since the derivative changes from negative to positive.
Since f prime changes from negative to positive. Or, what else could you say, Alexis? Want me to give you a hint? How do you get your shoes so white? They're new. What happens? What happens if they get a mark on them?
I try not to freak out.
Okay. What is F changing?
Yes.
How's it changing?
It's changing from decreasing to increasing.
To increasing, sorry, at that point. At that point. I should have had that here too. At that point. Okay? Not very complicated, is it? Backside. Okay, it says all we have to do here is find the relative extrema of this function in this open interval. Justify your answer. Notice we're talking about open intervals and not closed intervals, correct? They're very similar, so we don't have to look at the endpoints. So, Caitlin, what's the first thing we're going to do to find the critical numbers? Find the derivative. So what is the derivative here? 1 half.
Minus cosine
And we're going to make it equal to what? 0. So that means 1 half equals the cosine of x. Okay, so I'm going to go back in time. It's 1977, 42 years ago. I'm doing this problem on a test. First thing I do is this. I draw the unit circle. This point right here is 1, 0. This point here is 0, 1. Right here is a half, correct? I go straight up. Boom, I'm right there. Would you agree? And I know that x is equal to cosine. And y is equal to sine. I write those things down. So, what angle measurement is this? This is pi over 2, right? Pi over what?
3.
Pi over 3. X equals pi over 3. Also, if x is 1 half here, I could have went down here, right? Because x is positive in the first and the fourth quadrant. And I got to go from 0 to 2 pi. So this baby has to swing around all the way to here. And I know this is 2 pi. And 2 pi is equal to 6 over 3 pi. Correct? That's what I'm writing down to help me. So what is this? Yeah, I'm just a pi over 3 short, right? So this is 5 pi over 3. So those are my critical numbers. So here this is going to go to pi over 3. This is going to go pi over 3, 5 pi over 3. And this is going to be 5 pi over 3 to 2 pi. Is that making sense that I have 2 critical numbers and I have 3 columns? So now I'm going to put in a test value. Well, if I look at this baby right here, my beautiful drawing, this is pi over 3. This is pi over 2. I've got a couple of spots here. Does anybody know what those 2 spots are? Pi over 6 or pi over 4, right? Because this is a no calculator portion. So I got to choose one of those 2. I know what Chuck Kruger chose. What would Aiden choose? Okay, I chose pi over 4 too. Why did you choose pi over 4? Okay. I never thought about that. That works. Can I tell you why I chose pi over 4? Because I knew at pi over 4, both x and y are the same value. The cosine and the sine are the same. I knew it didn't matter. So if I got asked about sine, I knew it would be the same answer if I got asked about cosine. Do you understand what I'm saying? I know it's the square root of 2 over 2. You got that? You can get by and choose pi over 6. But I know the sine of pi over 6 and the cosine of pi over 6, they switch. But they don't do that at pi over 4. Everybody with me on that? Okay. So my test value, can you see this okay? Not very good. It's too big. I'm going to choose pi over 4. Now, Aiden, this is really nice in here, right? This is from pi over 3 to 5 pi over 3. I got a big swath. And I got nice ones, like pi over 2. And I even wrote down what pi over 2. I've got pi. And I got 3 pi over 2. Which one are you going to choose? I know which one I would choose.
Pi.
You choose pi. Okay, that's not the one I would choose, but that's okay. So I'm going to write negative 1, 0, just to help me out. Okay? I would have chose pi over 2, but I am A-okay with pi. All right? And over here, what do you suppose we would choose? I also know that 8 over 4 pi is the same as 2 pi.
I would choose 7 pi over 4.
Right, and here's the advantage of having 7 pi over 4. It's going to be the same as the cosine of pi over 4, correct? Now, why do I choose that? Because this right here is my derivative, correct? And I'm going to plug pi over 4 into cosine. I'm going to say it again. I'm going to plug in pi over 4 over cosine. So I'm going to write down 1/2 minus the square root of 2 over 2. Now, is that negative or positive? Well, 1 is the square root of 1. The square root of 2. The square root of 3. The square root of 4. Isn't the square root of 2 bigger than the square root of 1? Isn't this going to be negative? Would everybody agree? Then over here, I'm going to have 1/2 minus the square root of 2 over 2 because Aiden said, hey, if you pick the same one, it's going to be the same value, right? Because cosine has the same value because x has the same value in the first and fourth quadrant. Are we okay with that? So this also has to be negative. Now Aiden chose pi, so I'm going to have 1/2 minus a negative 1. Correct? Is that positive or negative? Positive. So what does this mean? That means f is decreasing. It means f is increasing. It means f is decreasing. Ty, does that make sense? Okay, Ty, what else I do to help me out, because I got to write a justification. Because it says justify what your extrema are. So this is what I do. I draw my little function. I know it's going down, and then at pi over 3, it turns around and goes up. What is this on my graph? It's a what?
Turnaround point.
What kind?
Relative minimum.
It's a relative minimum. So when I figure out that point, I'm going to say it's a relative minimum. Just like over here, I know my function's going up and then going down, right? Because I said up, down. So I draw those there. That's up to you if you want to draw that. But I'll draw that. You'll see me doing that every time. Ty, what is this?
Relative maximum.
Bingo. So I know what words to use. Now it says extrema. Extrema are the ordered pair x comma y, right? So over here, I have to figure out f of pi over 3. So that's going to be 1/2 times pi over 3 minus the sine of pi over 3. So my point is going to be pi over 3, comma, pi over 6 minus the square root of 3 over 2. Does everybody see where I got that? Because I know the cosine is 1/2, so it's not going to be 1/2. It has to be something else over 2. And I already used the square root of 2 over 2, correct? So my only other choice is the square root of 3. And that's my ordered pair. Now, you guys could go to your machine, if you're allowed to use the machine, and plug that in make sure you go 3 decimals. Does everybody understand that? Make sure you go 3 decimals. I'll say it a third time. You can go more than 3 decimals. No one's going to look at any more than 3 decimals. It's up to you. Make sure you round correctly. Everybody knows how to round, right? Something you learned, I don't know, before 6th grade or at 6th grade? You don't even remember, do you? Yes?
So what if you got to like 3 decimals and it was like 0.34496? What if you go to all the way like to that 5th decimal?
Okay, you write that.
Yeah.
Okay?
And they're just gonna look at the first ones.
Yes.
What if you like didn't round? Does it matter? Is going to be like
You want to know the truth or you want to hear a lie?
the truth?
Truth is they would allow you to write 3.449 or 3.45. Because this 6 means to increase that by 1, which makes that. And you don't have to write the 0. This is what AP allows you to do.
Okay.
What do you have to do for me?
Just write 3 decimals.
Round to 3 decimals. But they'll let you do either one. They'll even let you do this. You could have that all wrong if you want.
Just as long as you have that.
As long as you have these 3 right here. That's what they're going to accept. Okay? I've never told a class that before. Always made them round. Yes?
Theoretically, could you do 3.4509?
Yeah. Because they're not going to look beyond that 0.
Okay.
I could do this. Because they're not going to look behind that symbol of 0.
I'm gonna do it for everyone.
Okay. Yeah, I figured so. I figured in the class I wanted to be the first one that did that. Okay. Are we okay with that?
Yeah.
Alrighty. So on the next one we have 5 pi over 3. Do you see where I get, I'm going to plug it into my function, which is right here. Do you see where I get 5 pi over 6? Because if I take 5 pi over 3 times 1/2, I get 5 pi over 6. Does everybody see that? Okay. Sine is negative in the 4th quadrant. Does everybody see that? It's negative down here. So that's going to be plus the square root of 3 over 2. Okie dokie. Now, if you take a look, when you guys look through your book, you'll see a series of questions. I ask you to do the first derivative test. Okay? This is the first derivative test. And then they ask you for the justification, and they'll ask you to verify it on your calculator. Okay? I'm going to do the verification on your calculator first. Everybody with me? So, here's my calculator, and I will do it on a I will do it on a TI on a Casio. So I type it in. I know I have 2 extrema, a minimum and a maximum, correct? So I draw it. Oops, that's not what I want. I gotta change my window. From 0 to 2 pi. Draw. So I can see I got a minimum here, I got a maximum here, correct? If you got a Casio, you go Shift G solve, you hit maximum, you'll immediately go to the maximum, and it says 5.235987758. And your Y value is that. So you just got to take a look and say, okay, are those numbers? I've done that, they are. Okay? You know here this better be negative. And so I'm going to go second G solve again. I'm going to hit minimum. And that's the minimum value. So you just compare that to what you do on your calculator. Everybody got that? That's how you do it on a Casio. If you do it on a TI, it's a little bit more work. If you got an old TI by me, it doesn't work as fast. Can you see this at all? You can see that a little bit, right? Okay. And so it's 0.5x minus the sine of x. Make sure you're in radians. And I'm going to change my window from 0 to 2 pi. And everybody knows how I'm entering 2 pi, right? I'm just typing the pi number on your calculator. And I graph it a few times. I have determined, when I look at it, I can see a lot better if I do that. There's the graph. So I'm going to find the max. So I go second calc. I go to 4, which is my maximum. I have to get up here, go a little bit to the left. I'll choose there, and then I got to go past it and go to the right. Enter, and then ask you to guess, and then I hit enter again. And I come up with the same numbers. Okay, TI people, Casio people, do I need to do the minimum, or do you know how to do that? Jack, you're okay? Julia, you guys have Casios, right? So it was quick, right? Did it work okay on your TI? Okay. We'll finish up tomorrow, and then we'll start 3, 4.